Welcome to the Data Future channel. This is Shekhar and I am a data scientist. In this particular session, we are going to build a machine learning model to predict the employee attrition based on the different attributes of the employee. So here we are going to build a predictive model by using a random forest algorithm. That is, we will use the classification model, random forest classifier, and we'll check what is the accuracy, and also we can check the accuracy for the different um, uh, cross validation data set, and we will also try to improve the accuracy of the model by using a different uh, the, the the algorithm like grid search CV and the random search CV to find the best parameter and try to improve the accuracy of the model by using the best parameters. Okay, so let's get started. So first point here is we have to import the required libraries which are required for data manipulation, data visualization, and yes, of course, to build the model. Okay, so here I'm importing the pandas as a PD, numpy as a NP, matplotlib as a PLT, and Seaborn as a SNS. So pandas is used for the data manipulation, numpy is used for the numerical Python, numerical calculation like matrix multiplication or computation. Matplotlib and Seaborns are used for the data visualization. So yes, now next one is we have to read the data. So we are having a CSV file of the employee data, and we will read it by the pd.read_csv, and we'll check. I'm storing the data into EMP data, and I am going to see the first 5 rows, that is the dot head. That's it. So you can see here, you can understand the first data, what it is, in a satisfaction level, last evaluation, number of projects, monthly working hours, time spent in the company, if there is a work accident happened. Left is the target variable. We have to check whether employee will stay with the company or not based on these attributes. The promotion last 5 years, department, and salary. So this is all about the data set. Now here our target variable is left, where we can say if that employee is stay with the company or not. So we can predict the attrition, employee attrition, by using these attributes. Okay. Now you can see here there all are the numerical variables except that department and salary. So let's get and check what is the size of the data. Yes, now almost 15,000 records are there and 10 columns. Employee dot columns gives you the list of all the columns. Okay, then we'll check the what is the data type of each column. So employee data dot d types will give you the different types of the data type of that columns. Now you can see there are 2 objects means categorical columns, rest of all are the numerical one, this float and integer. Okay. Next one is we can check the information whether there is a null values, non-null values, the column number of rows, columns, and data type. So you'll get the all idea about the data set on this .info method. Next thing is we have to check whether there is any duplicate records are there, because with duplicates we can't process the data. So we can remove it so that we can reduce the computational cost. So here I'm using employee data in square bracket employee data dot duplicated, this method. So if I run this, I'll get all the duplicate records. So you can display it by using this, and you can check how many are these rows. You can see 3008. Now, yes, we have to delete that. So for that, I am creating a new data frame without duplicates. I am dropping the this duplicate records from the existing one, that is employee emp data dot. I am using a drop duplicate method to remove the duplicates. Okay, and later on I will check the shape or the size of the data set. Now you can see that after removing this, a new data frame is there, that is having 11,991 records and the 10 columns. Okay, we have to check the missing values also, because already we have checked here missing values. From here itself you will get the idea, but also we are checking by using dot is null dot sum. Okay, now we'll do some data visualization and the exploration. So we'll check what is the balance between majority and minority classes, because 0 means the employee stay with the company, and 1 means that employee will leave the company. Okay, so I think this data is very imbalanced. Okay, but we'll check later. We'll put as it is these records, and we'll go further and build the model. So we can do the visualization of this these categories by using a dot value, and I'm using dot plot kind is bar. Kind is bar means it will give you a bar plot for 0 and 1. Here itself you can see that more number of these rows for 0 and less number of rows for one category that is left. Okay, then this is the data set. Already we know that. Okay, what is the impact of salary on the employee at retention? We can check, and for that I'm using visualization basically. So without visualization also you can do that. Here you can see, if I use this thing here, let me show you the pd dot cross tab I am using. I am using the using the numbers between the salary and the target variable. So you can see here high, low, medium. So here the if it is you can check what is the difference between the employees staying with the company and those who are not going to leave the company based on the salary. Okay, so here in terms of percentage you can check how this can be what is the effect of the salary on the employee retention, or you can visualize here itself by using a cross tab, and I'm using a dot plot here and using a bar plot. So here itself this yellow the blue means 0 and yellow means 1. So you can see there is a lot of difference between this, but I think we have to calculate this percentage difference between these two. Okay, so from here there is no impact of salary we are saying, because you can see the more number, because again this data set is actually imbalanced, so we cannot easily identify which effect is impacting a more, but we will see later on. Okay, so department wise if you want to check these things, you can see here itself. Yes, department wise how many are staying with the company and not staying with the company, but we will visualize this because visualization gives you a complete idea. So you can see department wise these things you can find out. Okay, there is the employee leave the company or stay with the company. Next, we have to check how these numerical variables are distributed. okay, distribution of these numerical records, the features. So these are the having a float values, and here is having these integer values, and we are creating the numerical column list here. So what I'm checking, I'm collecting the list of the columns or the variables which are having the float values, and these are having a integer values. Both are the numerical variables, right? The same thing I'm using here, the list comprehension to separate out these variables. Okay, so now this is a complete list. Okay, here I'm going to plot the box plot, and I'll check whether there is any outliers are present in this or not. Okay, so here what I'm doing, I'm creating a subplot here, and 4 columns, and here I'm considering each column and iterating over it and plotting the box plot and giving the name as a column name. Okay, so here you can see there is a box plot, but in time spent in company is having outliers. Here is only 0 and 1. Okay, fine. Then the rest of the columns we are plotting. Yes, for satisfaction level, last evaluation, these are having and there is no outliers. Okay, so here we can plot it by using a histogram also. So a number of project dot plot kind hist, we can do it by plotting this. So you can check the maximum hours are in between 4 to 5. Maximum number of projects are 4 to 5. Then the data is distributed more for 150 hours. Okay, then time spent in the company is more number of this for 2 to 3. Then satisfaction level we can check. Satisfaction level is greater for 0.7, you can see here, and whether it left last evaluation is 0.55. Okay, so next one we have to do the feature engineering. So in feature engineering, first what we have to do, we have to convert the categorical columns into numerical one by using a encoder method. So here I am using a label encoder method, that is the label encoding by using a label encoder. That is, I am importing a label encoder from the sklearn.preprocessing, and then I am creating the object of this or the variable of that label encoder. Then I am having the two categorical variables. One is salary and the department, where I am converting this salary and the department this thing into I will use this encoder and fit underscore transfer. I'll apply and use it to the these 2 columns. Okay. Yes, now this is applied. Now you can check here on the last there is a department and the salary now converted into numerical columns. Okay. Now we have to split the data into target and independent variable. Target is our left. This left column is the target column, and rest of the all the columns are the independent columns or the independent variables. Now we have splitted this x. I'm using x. I'm dropping the left and considering all the columns. Here y is nothing but the employee data 1 left. Okay, this is your dependent and independent variable. Now we have to split the data into training and testing data set. Okay, so training we are considering 80% data, and testing we are using a 20% of data. So from sklearn dot model selection we are importing train test split method, and I am creating a 4 variables that is xtrain, xtest, ytrain, ytest, and I am using a train test split to split the x and y data, and test time I am considering as a 0.2 means 20%, and random forest is 42. We have to seed this value to put this data training and testing data set constant. So here you can check what is this train. So this is training, and we'll check the shape of this extend. Is these are the extend, but if you can check extend here, okay, extend head, I'll say. Okay, you can see here these variables are there, numerical variables, but here the satisfaction level is having a different range. Last evaluation is different. The number of project is from integer 1. This hourly average monthly hours are ranging from 235. So before that, what we'll do? So we can yes, the time spent in the company accident. So these are having a different um, what we can say different um, different skills. So what we have to do? So we have to bring them into a common scale, so that what will happen, there will be a instant we can reach to the to that accurate we will get the accurate results if you rescale it on the common scale. Okay, so here what I am doing, I'm using this thing. I'm using a standard scaler here from sklearn.preprocessing. I'll be importing a standard scaler, and I am creating an object of standard scaler. So this for feature scaling, you can use the min-max scaler or standard scaler. Here I am using a standard scaler. Now I will what I'll do, I will create I am going to rescale this xtrain and xtest. So I'm fitting this standard scaler to the xtrain, that is using a fit underscore transform, and for xtest I'm using a dot transform only for the X test. So here I am using a fit underscore transform, but here I am using a transform only. Why? This is there should not be a leakage of data, should not happen, or model should not learn from that test data. So that for that we no need without using a fit, we have to directly transform the data. Okay. Now our xscale and xtest data is got transformed. You can see here these things. Now what you have to do, so you have to go for the model development. So first you have to develop the model using a random forest algorithm. So random forest is basically an ensemble learning where multiple models are created in terms of n estimators, and it will take the combined output of this all the models. Means this is called as the parallel learning or the combined learning. Okay, so we are creating importing a random forest classifier from the sklearn.in ensemble. Okay, import random forest classifier. Then I am creating an object or to this random forest classifier. Now this model is ready. Now you have to train the model to fit it into extend, scaled and y-train. Okay, now extend and y-trained, I am putting the data to train the model. Now model is trained. Now that model is we are using for the prediction. So you can see we can have the predictions for this random forest dot predict I am using, and x text scaled we have to provide. Okay, so that we can check these things, and you can see here okay, so yes, this is the array. So you can see this array here is the model predicted these output. Okay, now we have to evaluate the model. So first we have to check what is the confusion matrix. So because it's a classification model, we have to check from the confusion matrix, and from the confusion matrix we calculate the accuracy, precision, recall and F1 score. So first we have to check the confusion matrix, how many are the true positive, true negative, false positive and false positive. Okay, so here from sklearn.matrix I am importing a confusion matrix, and I am creating the object of confusion matrix, providing the two arguments. One is the y test, means the actual values of y, and y pred is the value which are predicted by the model. Okay, so here I am printing the CM, that is confusion matrix. You can see that these values are correct values, means true positive and true negative, and rest of all the misclassifications. Okay, now I have to visualize it by using a heat map, that is sns.heatmap. I am using this object CM, and then not is equal to true, means I have to visualize these values also, and fmt is equal to d, means it will give the complete values here. So you can see these are correctly classified, because 1 1 here 0 0, but these are misclassified. So actually it is 1, but it is predicting 0. Actually it is 0, but 7 are misclassified as a 1. Okay, that's fine. So let's get to the accuracy. What is the accuracy of the model? So I'll import the accuracy score from sklearn.matrix, and I'll provide the y test and y prediction, and then I'll check the model accuracy. So model accuracy is 0.98, means 98% model is accurately predicting. Then same case I'm using the precision score, again using a precision score y test y prediction. The precision is also 98%. Then we'll check the recall. So recall by using a same, we can check it's a 90%, recall is 90%. So there is a slight difference between recall and precision. So that needs to be corrected by doing some modifications in the model. F1 score is also a harmonic mean between the precision and recall, that is 93%. Okay, so by using classification reports, so we'll get the all these values combinedly without without using a different the matrix. We can see all the matrix in the same report. So you can see that this recall, F1 score, precision for each class. Okay, and this model is doing good here. Okay, yes. So this is about the accuracy and the model performance. Now we have to check here is the feature extraction. So feature important matrix actually. So there is a random forest model. There is a one more the model is there, that is the feature importance. So by using this feature importance, we can just we can carry out the important features in the data set. Okay, so when you run this, so you can see here score list I am creating here. So random forest dot forest underscore import the feature underscore importance underscore, and from that I am creating these things so that I'll get the data frame of feature and its score in descending order. So this is the more importance is given in this particular, and less importance is given for these three cases. Okay, so you can visualize this also by using this bar horizontal bar plot here. By simply based on this, you can also create your own visualization. Yes, you can see here maximum importance is given to the satisfaction level, and these three time spent, average monthly, because these are the impacting factors, and last four are not that much of important one. Okay, now we will cross validate the results, the accuracy. So for that we'll use the k-fold cross validation, where I am importing the cross-val score from sklearn.model selection, and here I am checking a cross-val score. I'm storing that score. That will create a list of five accuracies. Okay, so using a model X-train, scaled Y-train, cross-validation is 5 and scoring is the accuracy. Okay, so it will give the accuracy for this it will check for 5 different data sets. It will give the 5 different accuracies. Now this is the accuracies. Now we'll check the what is the average accuracy. The average accuracy is 98.61%. Okay, so this is the accuracy of this model. Okay, average accuracy when we check for different data sets. Okay, yes. Now next thing is how we can improve the accuracy of the model. So that for this we are using a best hyperparameters. Okay, so how to check the hyperparameters? As for that we have to search the best hyperparameters, and for that we are using a two algorithms. One is the grid search CV and randomized search CV. Okay, here so I'm importing this grid search CV and the randomized search CV from the sklearn.model selection. So you can run this and you have to create your own parameters. Now I am selecting the n estimators, means the number of models we can say, or number of decision trees we can say. I'm considering 50 and 100. Okay, and max features I'm using this matrix, that is the square root. How many features are selected for the model this decision tree building, whether this log2 or sqrt, that too or none. Okay, so when I run this, now I have to create object of grid search. So grid search CV, I'm putting one argument, positional argument is random forest model, and second one is the param grid is the parameters here. Now I have to fit with the extend, scaled and wide train. Now grid search this object I am fitting to this extend, scaled and wide train, and then I'll get the best parameter here. Okay, so it will take certain time because it will check each and every possible combination of 50, and it will check for square root and log2. Then next time it will check for 100 and then square root and log2, and again for 100. 50 means it will create the 15 decision trees and check accordingly, and for 100 it will create 100 decision trees. So some time it will take, because grid search CV is basically takes longer time because it is checking each and every um, uh, every a possible combination of these parameters, or it will create a grid. But randomized search CV will require less time because it randomly select the parameters. Okay, now you can see here we have fitted this grid search to this, and now this object is will give a best parameters. Now here is we got the max feature is log2 and n estimated is 100. So what I'll do, I will put these base parameters here. Now here is the log2 and n estimator is 100, that are given by the grid search CV algorithm, and I'm creating a new model here now by using these two hyperparameters. Now I run this, and again I have to feed the model. Yes, the model is fitted. Now I'm using a K5-fold cross validation and check the accuracy of the model using this new model actually. The same case which we have did earlier for the cross validation. Now I am running the cross validation for 5 folds actually, and scoring will be the accuracy, and these are the 5 folds. Now it has created this one. Now I'll check the accuracy of the average accuracy of this particular uh, cross fold. Now you can see this is 98.61%. Earlier was again the same actually. So there is no improvement in the accuracy, means your model is working fine. There is no need to change the hyperparameters and all these things. So this is all about how we can predict the attrition, employee attrition, by using employee attributes, and we can build a random forest model. We can carry out the cross validation and hyperparameter tunings, and finally we can come out with the best model which can predict the employee attrition with 98% accuracy. Okay, so for this particular session, that's all from my side. If you have any doubt, you can reach out to me at 9764403272, or you can write me the email on this number, on this email address at gmail.com. Thank you. Thanks for watching.